We're going to talk a little bit more about some geometry today in lesson 126. We're going to talk about our quadrilaterals. Quadrilaterals are a polygon that has 4 sides, and there are many subclasses of quadrilaterals. We have parallelograms, rhombi, rectangles, squares, and trapezoids. So first let's talk about a parallelogram. A parallelogram is a quadrilateral, and if you remember quadrilateral, quad means 4 and lateral means sides, so just a 4-sided shape. The parallelogram has 5 properties that we discussed in lessons 37 and 39 if you want to go back and look at those. The opposite sides of a parallelogram are parallel. So this side is parallel to this side, and this side is parallel to that side. The pairs of opposite sides are of equal length. So this is the same length as this, and this is the same length as this. Angles opposite each other have equal measures. So this angle, actually let me get my pen. So this side is congruent to this side is congruent to this side, and both of these sides are also parallel. This angle is congruent to this angle, and this angle is congruent to this angle, okay? The sum of any 2 consecutive angles is 180. So this one and this one is equal to 180, this one and this one is equal to 180, and this one and this one is 180, and this one and this one is 180, all the way around. And that's because if you were to extend this line right here, this alternate interior angle we know equals 180. And this is the same as this, so therefore this is a straight line which equals 180, so therefore these have to equal 180 as well. Okay. Also, the diagonals bisect each side, which means that the angles are, the diagonals also bisect the shape. They cut the area in half. All right, moving on to a rhombus. A rhombus is a parallelogram whose sides all have equal lengths. So everything that we said about the parallelogram is true, but including the fact that this and this parallel side and this parallel side are all the same length. The diagonals bisect the shape. The opposite angles are going to be the same degree of measure, like that. So you have those characteristics there. A rectangle is a parallelogram in which all 4 angles are right angles, and they have 2 pair of equal length sides. So this side is congruent to this side, and they're parallel. This side is congruent to this side, and they're parallel. And we have 90 degrees, 90 degrees, 90 degrees, 90 degrees. Now a square is just an even rectangle, and that just means that, like the rhombus, all 4 sides are the same length, but like the rectangle, all 4 corners are 90-degree angles, and whenever these diagonals bisect each other, they're also bisecting the degree of measure in each corner. So it goes from 90 degrees to 45, 45. So what that means is when you bisect the square twice from corner to corner, you are creating 4 isosceles right triangles, because then this line is bisecting this line and this line is bisecting this line. So these are going to be the same length all the way around as well. So if this is the same length as this, and this is the same length, and this is the same length, and then all 4 of these lines in here are the same length, you have 4 isosceles right triangles within your square. All right, so let's talk about a trapezoid. So as you can see here, I have a trapezoid that is an irregular trapezoid, meaning that, yes, it has a pair of parallel lines, top and bottom, and it's cut by 2 transversals. But it's irregular because these transversals are not at the same degree of angle. Like this one is it's an obtuse angle, and this one is, while it's still obtuse, It's not quite as obtuse as this one. Now, the way we find the area of a trapezoid is by drawing a diagonal line from one corner to another corner and creating two triangles. And then we take the height of the trapezoid times the base, the length of the flat parallel side, and then divide that by 2. We add that for the first triangle and the second triangle together, and then that's how we get the area of the trapezoid. All right, an isosceles trapezoid is one where both of the transversals that cut here are the same degree of angle. They're opposite to each other, right? They're not parallel, but at some point they will intersect and make a perpendicular line because they have the same degree of cut. So what I mean by that is the angle here is going to be congruent to the angle here, and the angle here is going to be congruent to the angle here. And that means we can draw a line from here straight down and create a right triangle here and straight down and create a right triangle here, which means that this would then become a rectangle in the center, and we would have 360 degrees in here. This would be 90, and then we could find this degree of measure by knowing this degree of measure, or vice versa. All right, but these two lines are parallel, and these two sides are going to have the same length as well. All right, let me clear this, and we are going to talk a little bit more about chords and arcs. We talked a little bit about them in our previous lesson. I'm going to give it a little bit more thought. So if you need to rewind this and take some notes, or just feel free to pause. We've talked about this all year. Pause whenever you need to write something down. That's the best thing to do. Or listen for a while until I have the page full, and then pause and make sure you have all your notes and that you haven't forgotten anything. All right, so let me pause and clear this, and then I'll come back. We'll talk about chords. All right, so now let's talk about some chords in some circles and some arcs and all that good stuff. So here we have an illustration of two chords within a circle, and the chords are equidistant from one another as denoted by the central a point P, and we have two radii. Well, they're not full radii, but they're radius beginnings, and they end in two chords. They're perpendicular to the chords, and both of these segments of the radii are congruent in length. So therefore, if the two chords of the circle have the same lengths, then they are equidistant from the center of the circle, as illustrated by these two congruent lines here. Now let's talk about congruent arcs. Congruent arcs are arcs of the same degree measure in the same circle or in circles of equal radii. So these two, even though the arcs degree of measure are the same, the length is different, because this has a radii of 2 and this has a radii or radius of 4. So they're not the same in measure. Even though they have the same degree of measure, they are not the same length. So in order for an arc to be congruent in length, it has to be the same degree of measure in the same circle or in another circle that has the same radius. Now we're talking a little bit about chords. If we have two chords that are the same length. So for instance, in this circle, we have this chord and this chord are the same length. So that means their arc is the same in degree of measure and in length, okay, as the other arc. If two chords of a circle have equal lengths, if two arcs have equal lengths, then their chords will be the same length. So let's say this arc and this arc are both, 50 degrees. Then that means if we find the degree of measure of this, or the degree of length of this chord, then this chord will be the same. And that's just a way we can solve for lengths as we go forward, knowing what is congruent to what. And that's all we have for lesson 126. I will see you in lesson 127.